Right, this is video 27.2 covering pages 518 to 521. This chapter is really all about color. And the first thing you need to know is that you need to forget all the things that you learned in elementary school about colors and what makes colors. Because we're not talking about pigment. We're not talking about mixing paint. What we're going to be talking about is light and how the colors of light mix. So when you mix colored light, it's going to be different. So if you take all the colors, if you took red, yellow, orange, green, indigo, violet, blue, and mixed them all together in a bowl of paint, what would you get out of it? A nasty, yucky, brown, black color, right? Well, when you mix light and you're mixing all the colors, you're going to get white. So the light that we see from the sun, the light that we see coming from light bulbs is white light. And white light contains all the colors. So all the light that we see around us is actually red light and orange light and yellow and green and blue and all of that stuff. So when all the colors combine, we make light. When light colors combine, we make white. So the other way you can make white is by only combining red, green, and blue light. So if we have light bulbs that are red and light bulbs that are green and light bulbs that are blue, and we were to shine that, you could get white out of that. You don't have to have the other colors. All you need are red, green, and blue. So the reason that those make white is because inside of our eyes, remember we have rods and cones. The cones that we have in our eyes are stimulated by red light, some of them, and some of them by green, and some of them by blue. And so when all three of the types of cones in the back of your eye, in your vision area, center of vision, when they are all stimulated equally, then what we see is white. So if you change the amounts of red, green, and blue, that can create other colors, because if you've got more red stimulation than you have blue stimulation and green stimulation, then you're going to see a color different than just white. So that's where all the colors we see come from. It isn't because the light is mixing and making it. It's because the amount of frequency hitting the cones in our eyes change, and our brain tells us what color is there. So if you go to your television and you're adjusting the color on the picture of your television, the only colors that you have the option of adjusting are going to be red and green and blue. Anything that uses light to make their color, like the monitor on your computer or on your phone or in the TV, things that emit color are going to use the primary additive colors, which are red, blue, and green. Now, you've probably been taught that their primary colors are red, blue, and yellow, and that is not true for light. For light, they are red, green, and blue, because blue and yellow light do not make green light. So the only colors you need are red, green, and blue. Anything that is emitting light to make a picture is going to use red, blue, and green. So the additive primary colors are going to be red, blue, and green. So in art class, you probably learned that the complementary colors are going to be anything that's opposite of each other on a color wheel. Like in art, they tell you that blue and orange are complementary. Yellow and purple, I think. Yellow and purple are complementary colors. That's not the case in light either. So when you take a blue light and a red light and you mix them, what you get out of that is magenta. It's kind of this purpley pink color. I'll show you when we get to class. If you take red and you mix it with green light, then you get a yellow. And if you take blue and you mix it with green, you get cyan. So those are the colors that you get when you mix lights. So what happens is since red, blue, and green are all that you really need, and red, blue, and green together make white, complementary colors are going to be the two colors that when you put them together, you get white light out of it. So when the colors are added, they produce white. If you've only got two of them, those are going to be complementary colors. So we would say that magenta and green are complementary because magenta already has red and blue in it. So if you add that green to it, then you would get white. So magenta and green, yellow and blue, and red and cyan make complementary colors because they are white. They make white light when you put them all together. Now, where you see the magenta, the yellow, and the cyan always are going to be in a printer ink, okay? So if you go and you buy ink for your printer, you're buying black, yellow, magenta, and cyan. So keep in mind, remember, mixing pigments and dyes is completely different from mixing lights. So the reason is because pigments, the reason they look a certain color is because they absorb certain colors and reflect certain colors. So pigments that produce red, what we see as being red, are absorbing the cyan color. So cyan has to be subtracted from the white light in order for a pigment to look red. So we call cyan, yellow, and magenta subtractive primary colors. So when we buy ink, that's why we're buying black, yellow, cyan, and magenta, so that the cyan, what it's doing is it is taking out a certain color so that we see what's left. So those are the only three colors you need to subtract color from the light so that we can see the color that we want to see on the paper. Click on the link, take the quiz, and I will see you in class. Have a good evening.